All right, hi everybody. I thought today I would do the video just to kind of summarize everything that we've been working on. Hopefully this will help. And if you feel like it's better, I can add my own videos as well as Mr. Avancho videos to what we've been doing. All right, so what we're going to do today is put everything for chapter 6 all together into one problem. And if you notice, there's a big long list of things here that we're going to be doing when we graph a polynomial without just using our calculators as or Desmos as an aid versus gathering all this information. All right, so let's take a look at this problem. So the first thing we want to do is figure out the number of total roots. Okay, so our number of total roots here is 3. Remember, that has to deal with our exponent, our degree. So they have to be the same. Okay, so now we're going to look at the number of positive real roots. Okay, now remember, the number of positive real roots is Descartes' rule of signs, which tells us the number of sign changes in the original polynomial tells us how many times the graph is going to cross the x-axis on the positive side. Now, it may not be a nice integer, but it may be like the square root of 5, okay? But it's still a positive real number. So we're going to count the number of sign changes, right? So we have a positive to a negative, so that's 1, and then the rest are all the same. So there is one positive real number. So that means the graph crosses the x-axis on the positive side one time. And again, it could be positive 3 or it could be the positive square root of 3. I don't know for sure. Right? So now let's talk about the number of negative real roots. Right? So remember, negative reals means that I'm going to put a negative value in for x. So I'm going to put a negative x in. Everywhere I see an x, I'm going to replace it with negative x. Okay, and then remember, when you cube a negative number, it remains negative. When you square a negative number, it's positive. These two multiplied together are going to give you a positive. And this is going to remain negative. Now, the reason why the x squared is still negative is because you're squaring the negative x, and it becomes a positive value. You're not multiplying the negative and the negative, okay? Two negatives there don't make a positive. So let's count the number of sign changes here. Okay, so we have none, 1, and 2. So there are 2 negative real roots. Now remember, we have to decrease this by 2 because of our problem with imaginary or complex roots. So now, if you notice, one of the things that you should see is that the 2 plus the 1 gives you 3. That should always happen, that the sum of your positive and negative should always equal the total number of roots. Now, we have the other case, the other scenario, where we have 0 plus 1. That's only 1, and I still need 2 more. And that's how we're going to get our complex roots, or imaginary. Okay, so there could be 0 complex, because 2 plus 1 gives me 3, which means there are 0 imaginaries. Or 0 plus 1, that means there's only 1, which means there has to be 2 imaginaries. Okay? All right, so the next thing on our list here of things is the possible rational roots. Now remember, rational roots are P over Q. Now again, this is my possible list, which means that it could be these, it could not, I don't know, but it gives me a place to start. Now remember, that's going to come from factors of the last over the factors of the first. So the last is negative 9 and the first is negative 1. So, or positive 1. P is negative 9, which means we need to make a list of positive factors of negative 9. So you have 1 and negative 9. You have negative 1 and positive 9. You have negative 3 and positive 3. Q is 1, which means it's positive 1 and negative 1, because 1 times 1, and then negative 1 times negative 1. Okay, so P over Q, so I'm going to take P and put it over top of Q, which means that I'm going to take 1 over 1, and I'm going to get 1, and then I'm going to do 1 over negative 1, and that gives me negative 1. Then I'm going to do 9, negative 9, 9. And then I'm going to do negative 1, that gives me the same thing. I'm going to do positive 9, it gives me the same thing. And then I'm going to do negative 3 and positive 3, and it gives me the same thing. So these are my possible rational roots. These are the guys that I'm going to start with putting on the shelf to find my roots. Now, to help me, I'm going to go to Desmos. I'm going to go to Desmos. I'm going to put the polynomial in to Desmos, and I'm going to graph it, okay? And then I'm going to help myself by using that. All right, so I forgot the polynomial already. All right, so it is x cubed minus x squared minus 3x minus 9. Okay, all right, so I'm going to put that into Desmos. So x cubed minus x squared minus 3x minus 9. Okay? Oh, no, wait a minute. That's wrong. That's cubed. There we go. All right. So it looks like, all right, that this particular graph crosses the x-axis at positive 3. So I'm going to start by putting positive 3 on the shelf to find the root. Okay, so I'm going to put 3 on the shelf, and I'm going to do synthetic division. So we have 1, negative 3, and negative 9. Now, according to Desmos, this should have a remainder of 0. And it does. Okay. Now that gives x squared plus 2x plus 3 as my quadratic quotient. Now we can try and find another root, but it didn't look like there was any other place where the graph crosses the x-axis. But I would probably use quadratic formula here to find the other roots, which will probably be complex. So x equals, and then use my negative b plus or minus the square root of 2 squared minus 4 times 1 times 3 all over 2 times 1. Okay, so I'm kind of running out of room here, so I'm going to come up here, and I'm going to get negative 2 plus or minus the square root of 4 minus 12 all over 2. So that's going to make some sense here because they're going to be complex. Square root of negative 8 all over 2. So that's negative 2 plus or minus I square roots of 8 all over 2. So there's my other two roots. So they are imaginary. So 3 and negative 2 plus or minus I square roots of 8 all over 2 are my roots. Okay. All right, so that explains why we only saw one place where the graph crosses the x-axis. All right, so let's take a look at what else we have to find. Relative min and relative max. Now remember, those are our critical values or highest and lowest points. So remember, we used turning points to help us find these things. So let's talk about turning points. Now remember, turning points was the degree minus 1. So 3 minus 1 gave us 2 turning points, which means there could be, I would say, one relative min and one relative max. Okay. All right, so I'm going to go back into our Desmos. Okay, and kind of hopefully scroll up. There they are. And highlight these. I'm going to write down so I don't forget them. Okay, so this looks like my max. So negative 0.72 and negative 0.77. Let's do that. And that's going to be our max. And then our min is 1.39. Let's go that way. And negative 12.42. Okay, now I probably won't use all of that, all of the decimals, because we're going to graph it. And while we're here, let's find where it crosses the x-axis, the y-axis. That'll be helpful so that we can very easily graph that. That's 0, negative 9. All right? So let's go back here. And our relative min, like I said, was 1.4. Let's make it one decimal place. Negative 12.4. And our max is negative 0.7 and negative 7.7. Okay, so we're ready to graph a lot of the information here. Okay, so let's graph where it crosses the x-axis, which we found to be 3. So I'm positive 3. Okay, now I may need to change my y values, but I think we'll be okay. I just need to move this down. All right, our relative min is 1.4, negative 12. So 1.4, I think that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's put that guy right here. Okay, it crosses the y-axis at negative 9. That was right here, y right there. And negative 0.7, negative 7. 1, 2, 7. Okay. All right. So that's not too bad. And then let's talk about end behavior. Was the last thing on our list? Yep, end behavior. Okay, so remember this is a cubic and the Lie coefficient is positive, which means that it starts down, then up. Okay, so this graph is going to start at negative infinity. It's going to come up, make its turn, cross the x-axis, make its turn, or y-axis, excuse me, make its turn, and go through 3, and then go to positive infinity. Okay. All right. Now, I want you to pause the video, go through these entire steps by yourself, walk through all of this so you can pause and go back, and then when you're done with the next problem, so I want you to do this guy right here, see if you got what I got. Okay, so take a minute, pause the video, and go through all of it. All right, so hopefully you were able to complete that and pause and go back and forth to everything we went through. Here's all of my answers. Okay, total number of roots is 4. Number of positive real roots was 1. We had 3 or 1 negatives. So that means, again, our number of complex imaginaries were 2 or 0. My list of possibles was positive or negative 1 through 18, factors of 18. Factors of 1 for Q. So P over Q is just the factors of 18. I used my Desmos to figure out that the graph did cross the x-axis at negative 3 and 3. So I put negative 3 on the shelf. Now this is where it got a little different, because then you had to take the quotient of using negative 3, because this is now a cubic, put 3 on the shelf and get it down to a quadratic. All right, so there's our complex roots. So number of turning points was 3 or 1, because it was, remember, 4 minus 1 and didn't decrease by 2. So we actually have 3 turning points. So I used my Desmos to find them. Okay, and I had to go by 5s on my y-axis because my graph wasn't big enough. And my end behavior was up then up because it's quartic. Quartic. All right, so here's my graph and where it crosses the y-axis. All right, if you have any questions, please let me know. Remember, guys, we're going to get through this together. Wash your hands, social distancing, and we'll make it through. Have a great rest of your day.